Scientists observe negative time in quantum experiments. This is the topic of my video for today's video. And scientists have long known that light can sometimes appear to exit a material before entering it, an effect dismissed as an illusion caused by how waves are distorted by matter. Now research at the University of Toronto through innovative quantum experiments say they have demonstrated that negative time isn't just a theoretical idea, it exists in a tangible physical sense, deserving closer scrutiny. The findings yet to be published in a peer-reviewed journal have attracted both global attentions and skepticism. The research emphasized that these perplexing results highlight a peculiar quirk of quantum mechanics rather than a radical shift in our understanding of time. This is a tough stuff even for us to talk about with other physicists. We get misunderstood all the time, said Ephraim Steinberg, a University of Toronto professor specializing in experimental quantum physics. While the term negative time might sound like a concept lifted from science fiction, Steinberg defends it used, hoping it will spark deeper discussions about the mysteries of quantum physics. Years ago, the time began exploring interactions between light and matter. When light particles of photons pass through atoms, some are absorbed by the atoms and later re-emitted. These interactions change the atoms temporarily, putting them in a higher energy or excited state before they return to normal. The research led by Daniel Angulo, the team set out to measure how long these atoms stay in their excited state. That time turned out to be negative, Steinberg said, meaning a duration less than zero. To visualize this concept, imagine cars entering a tunnel. Before the experiment, physicists recognized that while the average entry time for 1,000 cars might be, for example, noon, the first car could exit a little sooner, say 11:59 a.m. This result was previously dismissed as meaningless. What Angulo and colleagues demonstrated was akin to measuring carbon monoxide levels in a tunnel after the first few cars emerged, and findings that readings had a minus sign in front of them. The experiment conducted in a cluttered basement laboratory bristling with wires and aluminum-wrapped devices took over 2 years to optimize. The laser used had to be carefully calibrated to avoid distorting the results. Still, Steinberg and Angulo are quick to clarify no one is claiming time travel is a possibility. We don't want to say anything travel backward in time, Steinberg said. That's a misinterpretation. The explanation lies in quantum mechanics, where particles like photons behave in fuzzy, probabilistic ways rather than following strict rules. Instead of adhering to a fixed timeline for absorption and re-emission, these interactions occur a spectrum of possible durations, some of which defy everyday intuitions. Critically, the research says this doesn't violate Einstein's theory of special relativity, which dictates that nothing can travel faster than light. These photons carried no information sidestepping any cosmic speed limits. The concept of negative time has drawn both fascinations and skepticisms, particularly from prominent voices in scientific community. German theoretical physicist Sabine Hossenfelder, for one, criticized the work in a YouTube video viewed by more than 2 50,000 people, nothing 2,050,000 peoples, nothing. The negative time in this experiment has nothing to do with the passage of time. It's just a way to describe how photons travel through a medium and how their phases shift. So we've made a choice about what we think is a fruitful way to describe the results. He said, adding that while practical applications remain elusive, the findings open new avenues for exploring quantum phenomena. So this is all about my video. Today's video, scientists observe negative time in quantum experiment. So thank you for watching this video. Stay tuned up to my upcoming next video. So thank you. Till then, bye bye. Take care.